Okay, so I just forgot my microphone again. So we're going to run through this quickly. 17, they give you this reaction. They say delta H is negative 540. You might think, why isn't the answer 540 or something like that? But it comes down to a vocabulary thing. They want to know what is the value of the heat of formation of HF. Well, heats of formation, which we abbreviate delta H with a little f, remember they're for a specific reaction. And the formation of HF, yes, it is forming HF from its elements. That's one of the definitions. But the other thing, and by the elements in their elemental state, so this has got to be a gas, I think that's a gas. But the other part of the definition is it's always the formation of 1 mole of HF, which means you would have half a mole of that and half a mole of that. So that's the key to the definition. A formation reaction is always the formation of 1 mole of HF. So you can see if this reaction makes 540 kilojoules of energy, the formation version of it would be half that amount. So I think the answer is B. Moving on to number 18. And number 18, it feels like we've done this one before. They're saying that water, solid water is becoming liquid water. That is melting. Imagine ice melting. So we know delta G already because they said at room temperature, which is true. Well, does it happen naturally at room temperature? If it does, which it does, ice melts at room temperature, delta G is negative. We already know that. If we're thinking about delta S has to do with order. And you remember that the particles in a solid, in a crystalline solid, are very ordered, whereas over here they're more spread out. That is increasing entropy, so entropy is going to be positive. And then delta H, well, if they're moving very slowly in the crystalline solid and they're moving faster here, they have to absorb energy. That's endothermic, so that would be positive as well. So the answer to me looks like it is, I guess C. It looks like C. And then finally, let's get on to number 19. 19 is just a Hess's Law one again. There's reaction 1, there's reaction 2. We're trying to form this reaction. I look for sulfur, it's in reaction 1, but the problem is I can't have 2 moles. I need 1 mole of that, which is going to make this 1.5, which is going to make that 1. And that reminds me that this is going to drop to 400, positive 400 kilojoules. Ignore oxygen because it's in more than one place, and then look for SO2. It's in reaction 2. It is on the product side as it should be, but we need 1 mole of that, which means we got to cut everything in half, including the oxygen, and so that is going to become negative 100. And you should always write it out and double check it. I'm going to check the oxygens really quick. If I have 1.5 moles on the left and 1.5 mole on the right, once I cancel, I'll be left with 1 mole of oxygen on the left, which is correct. So it seems like things are reasonable. And then we're just going to add up these two numbers, and it looks to me like the answer is A.